All right, let's talk about the analysis of combinational logic circuits. So we are going to be able to take a given circuit, convert that circuit into our truth table, and then from that table we'll be able to pull out our logic expression. So when we're looking at stuff like this, you're going to get a circuit here. What we're going to do is we're going to put some test points into our circuit so that we can put it into a table and analyze what we're doing here. So when you're looking at your circuit, you need to put a test point in after every gate. So we'd have a test point 1 here. There's another gate here, so we'll call that test point 2. We've got test point 3. Call this guy test point 4. And then test point 5 here. You don't need a test point after this last gate because that last gate's output is going to be F2, and that's what we're looking for to get our logic expression. So I am going to grab this guy because it's got a table on there for me. We're going to transfer over what we called each point here really quick. This is test point 1, test point 2, test point 3, test point 4, and test point 5. Okay, so we got that transferred over. Not too bad. So we're going to go through our table. This is supposed to be, we'll call this guy X instead, call this guy Y instead, and this guy Z. Okay? Alright, so X is our first guy, so it's off half the time, and then on the other half the time, and then Y is the same way. It just alternates a little faster. And then Z, we're going to go every other. All right, so we are ultimately looking for F2. So that's supposed to be a 2 there. We're looking for F2. We've got our inputs. So what we're going to do is we're going to look at our inputs, look at our test points, and then as we get through our test points, we should be able to figure out F2. So our first test point 1 here is just inverted X. So we're going to look at X and then invert them for test point 1. So it's 1, 1, 1, 1 as we go down, and then 0, 0, 0, 0. That one was pretty easy. Test point 2 is Y, and, because this is an AND gate, test point 1. Okay, so we're going to look at Y and test point 1. And we're going to get, that is a 0 for that first one. We're going to get Y, test point 1, 0. Y, test point 1, that's a 1. Y, test point 1, that's a 1. 0, 0, 0, 0. Okay? All right, so let's look at test point 3. Test point 3 is, if we're following along, Z and test point 2. So if we look at Z and test point 2 now, we get 0, 0, which is a 0, 1, 0, 0, 0, 1, 0, 1, 1 is a 1, 0, 0 is a 0, 1, 0, 0, 0, 0 is a 0, 1, 0 is a 0. All right, so we did all those. Now we're looking at test point 4. Test point 4 is just Z inverted. So if we look at that, it is just the opposite of Z. So we're going to go through like this. That, not too bad. And now test point 5 is test point 4 and Y. So if we're looking at Y and test point 4, that's an AND. So we're going to get test point 5 out of here. So test point 5, Y, and test point 4, 0, 0, 0 is a 0. 1, 1. So that's a 1. We get a 1, 0. That's a 0. 0, 1 is a 0. 0, 0 is a 0. 1, 1. We get a 1 here. And then 1, 0 is a 0. So we are almost done. We almost have our F2 in our truth table. So this isn't too bad. So our F2 is test point 5, because that goes up there, or, because this is an OR gate, test point 3. So if 5 or 3 is a 1, then we have a 1. Anything else is a 0. So 3 and 5, those are both zeros. 3 and 5, those are both zeros. Test 5 is 1. 1, 0, 0, 1, and a 0. Okay, so now we have our F2 solved in our table. So we're going to use the table to grab our midterms again, and then we're going to use our midterms to solve for F2. So if we look here, this is a 1, so we have in this spot here where it equals 1, we have not x, y, and not z. We have not x, y, and z. And then we have x, y, and not z. Okay? So our F2 is going to be equal to not x, y, and z, or not z, sorry, plus not x, y, and z, plus x, y, and not z. So that is our first example. If we're looking at our another example here, look at a guy that looks kind of like this, just a little bit different. Another way of doing it. So we got all of our test points pre-marked for us this time, so that makes it easy. We're going to set our x, y, and z up exactly the same. So 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 1, 0, 0, 1, 1, 0, 1, 0, 1, 0, 1, 0, 1. Okay? Makes that pretty simple for us. So test point 1 is just x inverted. So we're going to have the opposite there, that guy. Test point 2 is the test point 1 and y. So if we're looking at y and test point 1, we get 0, 0, 1, 1, 0, 0, 0, 0. Okay? Test point 3 is z and test point 2. So you put those test point 2 and z together, you get test point 3. So if we're looking at that, it is 0, 0, 0, 1, 0, 0, 0, 0. Okay? Test point 4 is just y inverted, because this is an inverter gate or a NOT gate. So you take y, you invert that. It looks like 1, 1, 0, 0, 1, 1, 0, 0. And then test point 5 is test point 4 and x. So if we're looking at x and test point 4, we get 0, 0, 0, 0, 1, 1, 0, 0. Okay? So now we've got everything. To get F1, we need to take test point 3 and test point 5 through an OR gate. So if either of them are 1, we're going to get a 1 for our F1. So test point 3 and 5, so 0 or 0, 0. 0 or 0, it's 0. 0 or 0, 0. 1 or 0, that's a 1. 0 or 1, that's a 1. 0 or 1, 1 again. And then 0, 0, 0, 0. Cool. So we've got 3 times where f1 is equal to 1. So we'll pull our midterms out of that. So we get in this column, you get not x, y, and z. In this column, you get x, not y, and not z. And then in this column, you get x, not y, and z. Okay, so that means our f1 is equal to not x, y, and z plus x, not y, not z plus x, not y, and z. Cool. So that is how you take a circuit to a truth table to a logic expression.